Hello and welcome to the video. In this video, we are going to talk through standard form, sometimes referred to as standard index form. Okay, so you can see from the slide I've got on the screen, I have a very large number displayed. This is the distance from our planet Earth to the sun in centimeters, and you can see it's a very large number. If I was to ask you to calculate with that number and work out the distance that a satellite would have moved if it did this journey 1,000,000 times, and you had to give me your answer in centimeters, what sort of answer would we be dealing with? You can imagine it's going to be a very large number. The number is probably going to be too big to fit on this screen. And that's when standard form becomes very helpful in maths. It allows us to work with very large numbers or very small numbers, and it also gives us an easier way of calculating with those large or small numbers. Okay, let's have a little look at standard form notation. So when you're given a number in standard form, it will always look like this. It will always take this notation. This number here is always between 1 and less than 10. So equal to 1 but less than 10. So this number here always has to be between those values. We always multiply by 10 because we're always going to be dealing with a power of 10. So if we had 10 to the power of 5, remember what that actually means. That means 10 multiplied by itself 5 times. And if I calculated that, it would actually give me 100,000. So what this power of 10 is representing, or what it is exactly, is 100,000. So that's telling me that 1.5 times 100,000 would give me the result of this standard form notation if I wanted to change it back into an ordinary number. So this number here always depicts the power of 10 that you have divided by in order to receive this number being between 1 and 10. So we've got a number between 1 and less than 10. We're always multiplying by 10 because standard form is based on powers of 10. And the index number here always corresponds to how many times you have divided this number by 10 from its original number to get to this point. If I do a few examples, that should be a little bit easier to follow. Okay. So if I wanted to convert this number into standard form, 43,000. Remember, with standard form, we would usually be converting very large numbers in and out of standard form. But for the basis of this lesson, we're going to deal with some smaller numbers, but the method remains the same. I'm going to change 43,000 into standard form. So the first thing I'm going to do is highlight where the decimal place is. This is where the decimal place would be in this number. I'm going to move the decimal place so that this number is now between 1 and 10. 1, 2, 3, 4. I'm going to drop the decimal point there so the number becomes 4.3. So you can see how I've done it there. I've took the decimal point, I've moved it 4 places to be left with 4.3. I couldn't have stopped here because I would have been dealing with the number 43, which is too big. And I couldn't have continued on to here because I would be dealing with the number 0.43, which is too small. So essentially what I've done there is I've divided by 10 times 10 times 10 times 10. I've divided by 10 to the power of 4. So 43,000 in standard form would look like this. This number is between 1 and 10. We're always dealing with the base number 10 times 10, and this 4 corresponds to how many times I had to move the decimal point in order to make this number between 1 and 10. Mathematically speaking, it means that I divided by 10 to the power of 4. I divided by 10 4 times to get this 4.3. But when we're just trying to visualize what's happening, we can visualize moving the decimal point 4 times, which is why I've ended up with an index number of 4. Okay, remember you have the ability to pause the video. So if anytime you want to pause the video and have a go at a question yourself, then you're free to do that. But I am going to talk through a few more examples. I'm going to convert this number into standard form. 123,000. I'm going to look at where the decimal point starts here, and I'm going to move it so that the number is between 1 and 10. 1, 2, 3, 4, 5. I'm going to drop the decimal point there. So it's going to look a bit like this. So this time I've moved the decimal point 1, 2, 3, 4, 5 times. So I've divided this number by 10, by 10 again, by 10 again, by 10 again, by 10 again. I've divided by 10 to the power of 5, which is why my standard form looks like this. 1.23, that's great because the number's between 1 and 10. Times by 10, that's always consistent. And this 5 corresponds to how many times I moved the decimal point. The decimal point had to finish here, because if I left it here, the number would be 12.3. That's too big. And if I continued to here, the number would be 0.123, which would be too small. Okay, so let's have a look at quite a small number. So because we're dealing with a small number, there's a few subtle differences in the method. First of all, we're going to highlight the decimal point. This time it's visible in the question, and I'm going to move it so the number is between 1 and 10. 1, 2, 3, and I'm going to drop the decimal point here to make the number 8.7. So what I've done is I've moved the decimal point and made the number 8.7. Mathematically speaking, what I've done is I've divided by 1 over 10, divided by 1 over 10, and then divided by 1 over 10 again. But that's quite a complicated way to think about it. So I prefer to think of it like this. We've multiplied by 10, we've multiplied by 10, and we've multiplied by 10. So I know I'm dealing with 10 to the power of 3. However, I'm going to be dealing with a negative 3 because the direction of my arrows is to the right. Because I've moved the decimal point to the right, I'm going to be dealing with a negative 3 for the index number. So let's just review that question. This 8.7 is correct because yes, this number is between 1 and 10, 8.7. It's always times 10. That remains consistent whether we're dealing with a small number or a big number. And this minus 3 is because I've moved the decimal place 3 places in the right direction, 3 places towards the right side of the page. And that is what you would expect. When you're dealing with a small number, a number less than 1, you would be assuming that you should end up with a negative index number. As I said, mathematically speaking, it's because we're dividing by 1 over 10 each time. But an easier way to think about it is multiplying by 10, multiplying by 10, multiplying by 10. Great, I know I'm dealing with 10 to the power of 3, but it has to be negative because I've moved the decimal place in the right direction and the number started as a small number. Okay, let's try another small number. Again, you have the ability to pause the video at this point if you want to have a go at this question yourself. It's a small number, so I'm going to expect a negative index number in my standard form. Again, the decimal point is visible, so I'm just going to highlight it there, and I'm going to move it to make this number between 1 and less than 10. 1, 2, 3, 4, 5. I'm going to drop my decimal point there. I couldn't have dropped it here because I would have been dealing with the number 0.5, which would have been too small. So my working out looks a bit like this. I've moved the decimal place 4 places to the right. Okay, so when I come to write my answer in standard form, this number is 5, between 1 and 10, so this is correct because it's between 1 and 10. It's always times 10, that's consistent. And the negative 5 comes because I've moved the decimal place 5 times to the right. So that's where I end up with the negative 5. Again, mathematically speaking, I've divided by 1 over 10 5 times. But an easier way to think about it is multiplied by 10, multiplied by 10, multiplied by 10, multiplied by 10, multiplied by 10 5 times. So I know I'm dealing with 10 to the power of 5, but it has to be a negative because of the direction that I've moved the decimal point. 5 spaces to the right and dropping the decimal here. Okay, the number 3 million. So first of all, I'm going to think about the number 3 million as in digits, which would be 3 and then followed by 6 zeros. So I'm going to use that in order to convert this into standard form. There's my number 3 million wrote out in digits, and you can see I've got 6 zeros. My decimal place started here, and I moved my decimal place 6 times to make this number 3. And this time I've moved the decimal place 6 times to the left. So my standard form is going to look like this. 3 times 10 to the power of 6. 6 because I've moved the decimal point 6 times, and it is positive because my movement takes place to the left. I started with quite a large number, so I expected a positive index number. Okay, last one to have a go at. 1678. Again, you wouldn't usually be asked to convert these into standard form, but for the basis of the lesson and learning the method, we can still go ahead and change this into standard form. Decimal place starts here. I'm going to move it 1, 2, 3 to the left, and I'm going to drop my decimal point there. So my working out looks a bit like this. I know I'm going to be dealing with the number 1.678, and my index number is going to be 1, 2, 3, and it's going to be positive because I'm moving to the left. So this number in standard index form would be 1.678 times 10 to the power of 3. Okay, so here is your first task. There is 6 numbers on the left-hand side, and there is 6 equivalent numbers on the right-hand side. We're dealing with normal numbers here, and we're dealing with standard form on this side. The 6 numbers on the left should match up with the standard forms on the right. However, one of them does not match up and is therefore the odd one out. Could you copy out the question and match up the correct matchings while highlighting the odd one out? Could you pause the video at this point and have a go at this question? Okay, welcome back. I'll just quickly go through my solution. And my solution looks like this. You can see where I've matched things up. 5,200, my decimal place started there. 1, 2, 3. So I'm dealing with 5.2 times 10 to the power of, and it's a positive 3 because I moved the decimal place 3 to the left. This one does not match up, and this one does not match up, because if I move the decimal place from here, I would only be moving it 1 to the right and dropping it here. So it would be 5.2 times 10 to the negative 1. Negative 1 because I went 1 space to the right. Remember when we're dealing with 5 million? A million has 6 zeros, so this would be 5 followed by 6 zeros. Therefore, to change it into standard form, I'd be dealing with an index number of 6. Okay, so now we have an idea how to convert numbers into standard form. We are going to have a look at calculating when those numbers are in standard form. So I'm going to talk you through two examples, one multiplication question and one division question. Then there'll be a few tasks for you to have a go at. Okay, so this is a very typical exam question where you're given two numbers in standard form and you're asked to calculate the answer in standard form. Again, usually we'd be dealing with index numbers much higher than this when calculating with standard form. But for the basis of the video and the basis of learning the technique, I've chosen some slightly easier numbers to deal with. Okay, so I've been asked to multiply 5 times 10 to the power of 3 and multiply it by 7 times 10 to the power of 5. Okay, you may find these questions sometimes come in brackets. That doesn't really alter the question you're going to do. All it does is ensure you're not getting things mixed up with the multiplication sign in the middle. The method for doing this is we look at these numbers first. The two numbers at the beginning of the standard form. And because it's a multiplication question, I'm going to multiply these numbers together. At the same time, I'm going to multiply the powers of 10 together. So my working out is going to look something like this. You can see I've multiplied the 5 and the 7 to get an answer of 35. And I've took 10 to the power of 3, multiplied it by 10 to the power of 5. Remember, when we multiply indices, the laws of indices tells us to add the index number, which is where this 8 comes from. So what I've got now is 35 times 10 to the power of 8. So I've multiplied the numbers. In this case, it was integers to get 35. There we go. And I've multiplied the powers of 10 to get 10 to the power of 8. At this point, your calculation may be finished if this number here is already between 1 and less than 10. But in this case, it is not. So this number is 35. It is too big. My decimal point is here. I'm going to move it one step so it becomes 3.5. Because I have moved the decimal place by one step, I also need to make a little correction to this index number. So my final answer, once I move my decimal place by 1, I need to increase my index number by 1. So when I end up with 3.5, my index number increases by 1 and becomes a 9. Again, look at the direction that my decimal point is moving. It's moving to the left, which means I'm increasing the index number. So here's my answer to the original question. And I've given my answer in standard form. Okay, let's have a look at the second example. This time it's a division question. There's a lot of similarities between the method and just a few subtle differences. First of all, I'm going to look at the numbers. So I've got 2.4 and I've got 4. This time it's a division question. So I'm going to do 2.4 divided by 4. Then at the same time, I'm going to take my powers of 10 and I'm going to divide them. 10 to the power of 2 divided by 10 to the power of 7. So my method, my working out, is going to look like this. 2.4 divided by 4. Well, 24 divided by 4 is 6. So 2.4 divided by 4 must be 0.6. Then we look over here. Because I'm dividing powers of 10, laws of indices tells me to subtract the index numbers, which is why I'm left with 10 to the power of -5. If I put those together, my answer is 0.6 times 10 to the -5. But again, this number is not correct. It is too small. It is less than 1. So I'm going to make a correction to this answer in order to present my answer in standard form. There's my decimal place. I'm going to move it 1 to the right to make this number 6. Because I've moved it 1 to the right, I have to make an adjustment here. And because my decimal is moving to the right, my index number gets smaller. I take away from my index number. So my final answer in this question is 6 times 10 to the power of negative 6. Okay, so here's a task for you to have a go at. Remember, you have the ability to pause the video at this point. I would like you to work through each of the 6 questions. Just make a note that some of them are multiplication questions, some of them are division questions. I have included brackets this time, so you don't get confused with the multiplication sign in the middle of the calculation, but it doesn't alter the method that you will be applying. Okay, I'd like you to pause the video at this point and have a go at calculating the 6 answers here. Okay, welcome back. I'll just go ahead and display my solutions. So my answers look something like that. Very well done if you got those answers correct. I just quickly want to talk about this question here, because when we go ahead and divide the numbers, 8 divided by 4 gives me 2. 10 to the power of 6 divided by 10 to the power of 2. I've got to subtract the index numbers. Gives me 10 to the power of 4. This one was already in standard form. This 2 was already appropriate. It was between 1 and 10. So I didn't need to make any corrections with my answer on this one here. I think with all of the other ones, you would have needed to make a little correction in order to get your correct answer. Okay, one more task for you to have a go at. So this time, some IGCSE extended questions that have come up in previous years. Starting at the top with converting in and out of standard form, and then we've got some calculating in standard form at the bottom of the screen. Could you pause the video at this point and have a go in your exercise books at all 6 questions? Okay, welcome back. I will display my answers for those 6, and they look something like that. You can see for the bottom 2 questions, I've tried to show you a little bit of working out where my final answer came from. Can you spend a little bit of time marking and assessing your work for these 6 questions? If you've got all 6 correct, then that is excellent. You've shown some very good understanding of how to convert in and out of standard form, and also how to calculate using standard form.